Welcome to 3.5 Solving Systems Using Technology. So we are going to go ahead and solve systems using Desmos today. Now, just as a disclaimer, not every single one of the problems on your test is going to be solvable with Desmos. We will have some like what we did in 3.1 to 3.4, where you will have to show work and you will have to do it by hand. There will be problems that we say you can use a calculator on, and this is the ones where Desmos is going to come in handy. Now, the first thing I'm going to do is I want you to open a new tab. That's desmos.com/matrix. And that's what you see on the right-hand side of my screen. So I'm going to go ahead and kind of work with this calculator throughout the entire lesson. So this is going to make solving word problems a lot easier for you because you can use Desmos to do some of the number crunching instead of having going through the steps of substitution, elimination, and Gaussian elimination. So let's start off with just regular system problems. The first thing I'm going to do is I'm going to write my augmented matrix. Now remember, that is just the matrix of the X, Y, Z answer values. And so in this case, I have 3 rows and I'm going to have 4 columns. So I'm going to go ahead and write out -6, +5, 2. And if you want to, you can draw the line. You don't have to. And -11. Everything has to be in order. So if I started with X, Y, Z, I need to continue with X, Y, Z. So I'm going to have -2, 1, 4, -9, 4, -5, +5, -4. Now, the way that this is going to work in the calculator, you're going to take your matrix. I'm going to call it a new matrix, and it's going to be A. I'm going to say I want it to have 3 rows, and I want it to have 4 columns. And then I'm going to go in, and I'm going to type in all of my values from my matrix to -11, all the way down to -2, 1, 4, -9, to 4, -5, 5, and -4. And then hit enter. And so once my calculator has recognized this as matrix A, I can do this RREF function in the bottom left-hand corner. That stands for reduced row echelon form. So it is going to take Gaussian elimination even further. So I'm going to tell it I want it to perform reduced row echelon form on matrix A. I hit enter, and if you notice, when I take this matrix back to systems, what it's going to do is it's going to tell me X is 4, Y is 3, and Z is -1. And so that means my solution is 4, 3, -1. So reduced row echelon form is just a further step of Gaussian elimination where you don't even have to do the final steps of solving for X, Y, and Z using the equations. You get it all from Gaussian. Now, your calculator is doing this for you. So it's saving you a little bit of the hard math of getting there. But again, these kinds of questions where we let you use the calculator are going to be tied to problems where the numbers don't always work out so nicely, or they're too big, or the equations themselves are kind of hard to write. So we don't want the solving part to be the hard part of the problem. So let's go ahead and let's try number 2. I'm going to go in. Again, make sure you're careful. I'm going to come and move everything to the left-hand side before I start converting it into my augmented matrix. So I'm going to have X plus 4Y plus Z equals 0. The side you move it on is completely preference. I just like moving everything to the left, so that's usually what I do. And then I'm going to go ahead and put it into my augmented matrix. So 3, 3, 3, 18, 1, 4, 1, 0, and 2, 5, -1, -9. And then I'm going to go ahead and hit new matrix, and maybe we'll call this one matrix B. And this one still has 3 rows, 4 columns. I'm going to type in 3. Oops, I wanted to see if it was going to let me hit enter. It didn't. So I'm going to just have to click each one. 3, 3, 3, 18. And then we have 1, 4, 1, 0. And then 2, 5, -1, and -9. Enter. And then I'm going to go RREF B. And you can see it's giving me X is equal to 3, Y is equal to -2, and Z is equal to 5 to lead us to our answer 3, -2, 5. And again, I'm going to say this as many times as I have to. You cannot use the calculator on every single problem. We will have problems that say non-calculator where we expect you to fully show your work. And we will have problems that say calculator where you can just write your system, your augmented matrix, and your answer. But we'll kind of talk about all of that on review day. So let's go in and let's tackle some of these word problems. So the first one says 3 orders are placed at Pizza Hut by Ruby, Simon, and Chris. 2 small pizzas, a liter of soda, and a salad cost $14. I like to come in as soon as I can kind of identify what I'm looking for. I like to kind of write it down. So I'm trying to find the cost of a small pizza. And once you start seeing things listed, it kind of gives it away. Small pizza, we'll say a soda, and the last item is a salad. And so when you write this as a question on your test, we will expect to see your variables defined. We will expect to see the equations. So first one would be 2x plus 1y plus z is equal to $14. And that's coming from, let me just highlight that sentence. And then we have 1 small pizza, a liter of soda, and 3 salads cost $15. So X, Y, 3Z cost $15. And then the last one, we have 3 small pizzas, a liter of soda, and 2 salads cost $22. So I'm going to have 3 small pizzas, a liter of soda, and 2 salads cost $22. So this is my system. You must write the equations. You have to write the equations. And then you transfer it to an augmented matrix. So 2, 1, 1, 14. 1, 1, 3, 15. 3, 1, 2, 22. And then I take that to my new matrix C. Oops, let me delete. Enter C, new matrix, 3 by 4, and I type all of my matrix values in. Now, I do get the question, what if I wrote my equations in a different order? So say you wrote the first sentence as your third equation instead of your first equation. That shouldn't make a difference in your X, Y, and Z value. The only thing that will change kind of what we're getting is if you don't write them as like you read them. So I put pizza, soda, salad. So say for instance, you wrote soda, pizza, salad. That would still be fine. You just have to make sure when you define those variables, you know what variable represents what. Otherwise, your prices are going to get mixed up. So I have C, RREF, C, and this tells me that we have X equals 5, Y equals 1, and Z equals 3. Now, one thing that we talked about with word problems is if you have a word problem, you should have a word answer. So I'm just going to go in and say small pizza is $5. Liter soda is $1. And a salad is $3. And that will take care of putting context back into the numbers that I got. Now let's go ahead and flip to the back and see what we have there. So the sum of three numbers is 16. So I'm going to kind of highlight as I go and pick what sentences I have. The sum of three numbers is 16. The largest number is equal to the sum of the other two. And 3 times the smallest number is 1 more than the largest. So you kind of have to be able to pick out where these problems kind of start and end. So we're going to go in, we're going to write our 3 equations. In the case of 3 numbers, I'm just going to go ahead and call X my first number, Y my second number, and Z my third number. And so let's go ahead. Sum is addition. So X plus Y plus Z is equal to 16. The largest number, so I'm going to say this is the smallest. Let's kind of call it that. Small, large, and we'll do medium in the middle. So the largest number is, so I'm going to say Z is equal to the sum of the other two. So X plus Y. 3 times the smallest number is 1 more than the largest. So 3 times the smallest is going to be 3 times the smallest is 1 more than the largest. So that largest is Z plus 1. So 3 times the smallest is 1 more than the largest. So now that I have my 3 equations, I'm going to go ahead and put this into my augmented matrix because this is one that we can go in and use our calculator on. And I'm going to have 1, 1, 1, 16. Now for the second one, you have to be careful because I want everything to be on one side. So I'm going to kind of just draw a little arrow down here because I'm going to have to move both. I'm going to have negative X minus Y plus Z is equal to 0. I'm going to have 3x plus 0y minus z is equal to 1. And so those are the values that I'm going to put into my matrix. Now remember, you don't have to necessarily move them to the left-hand side. I have a lot of people who would just rather put minus z on the right-hand side, and that's okay. We're going to have different signs, but we should still have the same numbers, and we should still get the same answer in the end. So I'm going to go ahead, matrix D, 3 rows, 4 columns, 1. And if you ever run out of letters, you can still type in here. I know they only give you a certain limited number on the keyboard, but you can type in whatever letter you want. You can even go in and override another matrix that you've already made. I'm just trying to do what's easiest and fastest for the sake of the video. -1 and 1. Hit enter. RREF D. And this tells me that X is 3, Y is 5, and Z is 8. So this does ask us to find the product, and product is multiplying. So 3 times 5 times 8 is going to give me 120 because 8 times 5 is 40 and 40 times 3 is 120. Now moving on to number 5. Lauren bought 3 types of candy for Halloween. We've got Nerds, we've got Skittles, we've got Airheads. She brought home 14 bags of candy and paid $33.75. She remembers seeing a sale sign that said Skittles were twice the price of Nerds and Airheads were 75 cents less than Skittles. She has 3 bags of Nerds, 6 bags of Skittles, and 5 bags of Airheads. She wonders how much each bag cost. So I kind of kept reading because I was waiting to see what we're actually looking for. So we're looking for the cost of Nerds, the cost of Skittles, and the cost of Airheads. So we know in total, we know how many bags she brought. We know how much of each bag she brought. So I really don't even need that information. But I know she has spent $33.75, and this is the amount of bags of each one that she bought. So I'm going to go ahead and take 3x plus 6y plus 5z equals to $33.75. And then we have, she remembers seeing a sale sign that said Skittles were twice the price of Nerds. So remember, this is the one where you have to ask yourself, which one is more expensive? In this case, Skittles are more expensive. So y is equal to 2x, 2 times the price of Nerds. And if you ever get confused, make a table, plug some numbers in, see what works out and what doesn't with what you're trying to decide. For the last one, Airheads were 75 cents less than Skittles. So Airheads, which are Z, are the price of Skittles minus 0.75. Now, again, we're going to take all of this information. We're going to plug it into an augmented matrix. So I'm going to just sketch one out really quick. 3, 6, 5, 33.75. Now, -2, because I'm going to move that negative or that 2x over, 1, 0, 0. And then I have no x's. I'm going to move that y to the left-hand side. So that's going to become -1, positive 1z, and negative 0.75. And then I will go to E, new matrix, 3 rows, 4 columns, 3, 6, 5, 33.75, oops, 0.75. And then I'm going to have -2, 1, 0, 0, and 0, -1, positive 1, negative 0.75. Enter. RREF E. And so this tells me that the price of Nerds, I'm just going to kind of write it already. Nerds is $1.50. The price of Skittles is $3. And the price of Airheads is $2.25. Now, just to point out again, you need all of this information that is currently on my paper to get full credit on your test. You have to define your variables. You have to write out your equations. You have to write your augmented matrix, and you have to answer the question in context. So put some meaning back to those numbers. Don't just give me an ordered triplet, and don't just give me x equals y equals z equals. Tell me what those numbers represent. Now, for the last problem that we're going to do. French roast coffee costs $5.20 a pound, and Colombian coffee costs $4 a pound. How much of each kind should be used for a 100-pound mixture? So basically, they want us to go in and see how much of each. So I'm just going to start off with pounds of French roast and pounds of Colombian. Just going to abbreviate it. And they said this is going to be a 100-pound mixture. So x plus y equals 100. Now, this is only a 2-variable system, but it's a little bit more challenging because we have some things to consider. So it says that they can sell this 100-pound mixture for $4.72 a pound. So we know that there's some prices associated with the cost of a French roast and a Colombian. So I'm going to tie that to the variable it's supposed to go with. So I'm going to say 520x plus 4y is equal to 472. But what you have to be careful of is whenever you have 472, that's the price per pound. And we're planning to make 100 pounds. So that means this number on the right-hand side of this particular equation isn't $4.72. It's actually 472 because we have to go in and multiply that value by 100. So my augmented matrix ends up being 100 and then 5.24472. And so this time, when I go to plug in my new matrix, it's going to have 2 rows, 3 columns, and I'm going to have 100, and I'm going to have 5.2, 4, let me back up, 4, and 472. And then we'll still do RREF F. And this tells me we need 60 pounds of French roast. And we need 40 pounds of Colombian coffee to make this particular mixture. So whenever you only have 2 variables, that's okay. Just remember it's going to change your matrix dimensions. Instead of being 3 rows, it becomes 2 rows. Instead of being 4 columns, it becomes 3 columns.